math lovers, welcome to notes number 21. Today we're going to work with some word problems, some modeling linear equations. I'm working out of the textbook. This is section 1.3. A couple things for you to keep in mind today. In your textbook on page 97, there's some great phrases for you to look over. Remember, all of these words have special mathematical meaning. I want to remind you that rate times time is equal to distance. You can also think about that in terms of time is equal to distance over rate. And there are lots of formulas which I think you're already familiar with on page 101. So I've picked 4 problems out for us to do. We're going to talk about percent change. Remember, that's the difference over the original. We're going to also talk about some mixture problems. I like to think of them as start, add, get questions. Okay, so the first one, number 35, I've drawn the figure here. They want to know what the area is. Okay, so they want to know the area of this shape. Now you could stare at it, let it talk to you. Everybody might see it a little bit differently. I'm thinking right away that this is, there we go, a quadrilateral, and I just have that section that's missing. So I would say my total area is equal, or excuse me, the area of this L shape is my total area minus the part that's missing. Okay, this is just the way I see it. So I would do 8 times 2x, which would be 16x. And then the missing section here would just be 4x. So I know my area is going to be 12x, okay? Somebody else might not look at that exactly the same way. Maybe you want to cut it off. You could cut it off here. You could cut it off here. In which case, I guess if you cut it here, that would be 4x for this block, and that would be 8x. 4x plus 8x, that would still give you the 12x for your area. And I don't have units here, so it would be whatever unit square it is. Number 37 asks me to find the sum. It tells me, the sum of 2 consecutive natural numbers is 525. Find the numbers. Okay, so let's see. We need a let statement. We need to tell our reader what we're doing. So let's say let n equal the first number. And then since they're consecutive, I would say n plus 1 is equal to the second number. Now, I picked this one to do as an example. This is way easier than I would ever have on a test or quiz. I would probably tell you about the sum of 2 consecutive evens or 2 consecutive odds. If they're consecutive evens, you'd have n and n plus 2. If they're consecutive odds, it's n and n plus 2 as well, because remember, they're always 2 apart. The sum is 525, so n plus 1 is equal to 525. Now, I usually find the kids in my math class want to just go ahead and take 525 and split it in half. Yeah, it's going to work here, but you know, be ready, because when I'm giving you a quiz or a test on this material, oh, this should be a 2. 263. I can't do 2 things at once. I should just be focusing on my math. When I'm going to give you a quiz and test on this material, I'm going to ask you a little something more, kick it up a notch, okay? Make it a little bit more exciting than just the sum of 2 consecutives, and I'm going to always want you to give me an equation for that, okay? Number 47 here in your textbook is going to ask you to, let's see, it says 12 is 1/2% of what number? So I like to kick it back to the old days. Remember back in pre-algebra you did is over of is equal to percent over 100. And that's just such a great formula to use because it works every single time. It says 12 is, so your is here is 12. 1/2%, so the 1/2 is going to go right here in the percent part. You don't even have to worry about changing the decimal or changing it to a decimal. The 100 stay there. Of what number? Of what number is your unknown? So all you have to do, my friends, is cross multiply. So you have 1200 is equal to 1/2 x. You want to unglue the 1/2 and the x. They're glued by multiplication. The opposite of multiplication, multiplication is division. So I'm dividing by 1/2. Or you can multiply both sides by the reciprocal, and that's 2,400. Okay, so that's a great problem. The last problem I want to do with you is a mixture problem. And if you're fast forwarding through this video, this is the point where I would think that you should slow down and you should try this start, add, get problem with me on normal speed. All right, this is, I don't know if I think a lot of you have done this before, but this always trips kids up. I like to do these as charts. So I will say this is a start, this is an add, and you're going to get Okay, so it's a start I'd get problem. And I'm going to have a percent here. I'm going to have an amount and my total. Okay. So the problem says to me that I'm starting with solution 1, which is 25%. I don't know what it is. It doesn't say what it is. 25% concentrate. And I don't know how much I have. Solution 2 is 50%, and I still do not know how much I have of that. I'm going to mix it together, and I'm going to get 5 liters. So here I'm going to get 5 liters, right? 5 liters of a 30% solution. So I'm going to go ahead and put that 30% in there. So I started with 25%, and I am adding a 50%. Now, it makes sense that if I'm starting at 25% and I'm adding a 50% solution, that the percentage of the concentrate, it's going to go up. Totally makes sense. Okay. But here's the problem. I don't know how much I have here. Some kids will say to you, hey, Glennon, put an X here for the amount. Okay, great. And then go ahead and put a Y here. But wait a minute. We don't want 2 unknowns, do we? So let's think about it. So if here's my first mixture and here's my second mixture, and I'm going to mix them together into a bowl. All right, so here's my bowl. You can tell why I'm not a geometry teacher. All right, so if I know that I'm going to get 5 liters all together, my first mixture, say, is 3. How much is this mixture? Yeah, 2. Okay, good. We got that. All right. Suppose over here it is 4. What is it over here? Good, 1. All right, so it has to be 5. Okay, so here we go. If over here is X, how much do I have over here? You got it. You got it. So it's going to be 5 minus X. All right, because the sum has to be 5. So it's 5 minus X. It's a nice little trick. Put it in your back pocket. Keep it with you. Your total over here, we're going to take the percent that we have, multiply it by the amount, and then that's going to be my total. That's how much concentrate I have in the final mixture. I have 25% of X, and then I'm going to have 50% of 5 minus X, and then I'm going to have 30% times 5. Okay? So I'm starting with something, I'm adding something, and I'm getting something. So this makes sense. I'm going to take this amount, and I'm going to take this amount, I'm going to add them together. So here's my equation, 0.25x plus, add the second amount, 0.5 times 5 minus x. And I'm going to get this final solution over here, which is going to be 0.3 times 5. Okay? So let's go ahead and just solve this equation. It's easy peasy now. 25x plus 2.5 minus 0.5x equals 1.5. All right, let's get all our terms together. We got this and we got this. We're going to take away 0.5. That's going to be negative 0.25x. And bring this 2.5 over here. It becomes negative, so that's going to be negative 1. I divide both sides by negative 0.25, and x is equal to 4. Oh, that's so nice, isn't it? If x is equal to 4, what is 5 minus x? Right, it's going to be 1. And I'm dealing with liters, so I should say liters here. Okay, so there's my final answer. Now, stop when look at your answer when you do these. Make sure it makes sense. If I had 7 liters, right, I'm not going to have negative 2 liters. Or would I? Well, maybe it's an evaporation question, unless it's an evaporation question. That would be really awesome, wouldn't it? An evaporation question. Oh, maybe you'll see one of those tomorrow. Have fun with your problem set.